like to start by introducing Hans Geldenhuys, the director for SES Africa. And Hans, when I had a look at your profile, you have been in the industry for many years, and you had a role in Intelsat as director for Africa that has transitioned into this new, bigger, wonderful business of SES. And I'd also like to introduce Christelle Meyer. And Christelle was actually, I would say, probably the initial spark for the program that has then actually just taken flight. And Christelle, you and I met. We were introduced by one of the South Africans working for Intelsat at the time in the USA. And we built this program and launched it during the toughest time of the pandemic. So it's gone from strength to strength.
Thank you, Judy, for the introductions. We sit in front of you today as a new company, a new co called SES. Now, SES is not a new brand in the industry. It's actually now, as a new co, the compilation of Intelsat and SES as one company. I would like to introduce the new SES to you today, which comes with a vast amount of additional, not just resources, not just technology, but also our capabilities in space, which is what we're thriving towards and what we're obviously looking to expand on continuously. SES, as this new co, is a space solutions company that empowers business governments with integrated purpose-built satellite and connectivity solutions. As satellite as the main connectivity medium, we obviously integrate into the wider scope and the network of connectivity mediums to really provide solutions that is purposely built for the solutions and applications that we're wanting to serve. I think our quote is really the purpose. What we do is we want to make a space to make a difference. Space as the real access medium, and the platform that we want to use. Our vision is to really transform space into a platform for innovation and to create new possibilities. And as this new co, this is exactly what we're striving towards. I'll share a little bit more in the presentation coming of what we do differently, and how we can access space differently to ensure that we're really driving the technology and the innovation much further than we ever did in the past. And then very importantly, our mission. We are building a secure, collaborative space ecosystem and a responsive ecosystem that drives lasting human impact. I think this is really for us, as a credo, specifically in Africa, something that we carry close to heart is really connecting people and connecting the unconnected, creating connectivity mediums that have an impact in people's lives. Just a quick snapshot of where we are today already. As this new co, we serve far north of 60 government organizations. This is big business for us. As a prime media, we serve close to 11,000 TV channels. We're the largest connectivity partner for commercial airlines today, with 30 commercial airlines connected with our satellites. And then majority of the 8 out of the top 10 MNOs globally, as global companies, we serve through all their opcos around the globe. So how do we really impact these lives that I spoke about? There's various verticals and applications that we could connect via satellite today. Looking at from very high level, there's a commercial silo, a government silo, and then something that we call evolving applications. This is really we were driving, the new tech in space. From a commercial perspective, as I lead it towards the largest commercial connectivity provider for aviation, we connect all planes, with the capabilities from a satellite perspective through our space mediums and multiple orbits that we can access through that. Cruise and all mobility applications really, but cruise being a very, very large, commercial silo for us. And then telcos and MNOs. This is with the focus on Africa. And, in my presentation, I focus a lot on Africa, I think, where we all, have our roots and, which is very relative to us. From a mobile network operation perspective, we are serving all the large MNOs across the continent. Africa is a very difficult continent with 54 countries to connect. A lot of these countries are still struggling with resources, and the MNOs are really instrumental to drive that connectivity space into these countries. And where satellite fits in perfectly with that is that we are pushing the boundaries of where they can connect people further and further with the ease of access over satellite. So satellite is really easy to connect for rural sites and really the ultra remote areas with small remote terminals, putting up a node, connecting villages and aspects like that, and really supporting these telcos and MNOs to push their networks further, and then also to go back to that credo of ours where we are really pushing to connect and to create access to connectivity for people that don't have access to that. And in Africa, that is still very much the case. And then energy and mining, which is very important for us. I think this is from a commercial and a large corporate perspective, very, very important for us. Government, I won't touch on this individually, but this is a lot of defense networks, as well as border security. This can be connecting embassies around the globe, and various other aspects that governments needed. And then for me, very, very importantly, are evolving applications. This is where stuff that we won't see today as much, but where we actively working on to use satellites as a connectivity medium to really drive the technology further and further. Connected vehicles. This is something that will be a big reality for us in the future. There is already applications that connect vehicles, but if you see the way that vehicles are being designed today, a lot of electric vehicles, a lot of software defined vehicles, where these vehicles will be connected via satellite, the manufacturer send prompts, send updates, see the parameters on these vehicles and certain aspects like this. So this is really important for us to ensure that we stay with what the requirements are and the needs are of these companies around the globe, and then see how we could utilize satellites to connect them. And then various platforms, we call it hosted payload platforms. This can be in various forms, and I'll go a bit deeper into the type of satellites that we get and the type of platforms that we serve. And really creating the sovereign systems, dedicated applications and dedicated access to satellite systems, maybe sometimes not as commercial as we can access it today. But really, we are focusing on all the aspects, commercial, government, and then also, where the technology are taking us to push the boundaries of connecting people through satellites today. So SES today, and I want to give you, this is a really, really interesting slide to give you a snapshot of our fleet today. Today, we are capable of serving the industry and the markets through 3 orbital planes. Low Earth orbit, this is through our partnership with OneWeb, whereby we've got a partnership agreement, and where we use their low Earth orbit applications to productize that and then take that to market. Our MEO constellation, SES was at the forefront and is today the only commercial organization that's got a MEO constellation and that can provide technology and connectivity over a MEO constellation. We've got 30 satellites in middle Earth orbit. And then lastly, our geostationary satellite, if you can click one more for me, you can see it build out there, Judy. And where we've got over 90 geostationary satellites, whereby we can then design and productize applications over. Through these 3 orbital planes, we cover 99% of the world's populated regions. We have, to connect to these satellites, we've got over 150 teleports of our own and more than 50 points of presence. And this is continuously growing as our networks grow as well. So really creating the access in space, creating the networks on the ground, having that handshake between the applications in space and on the ground, we are capable of really delivering the services as I gave a snapshot of earlier. The next slide I want to use are breaking down really, when I speak about multi-orbit and GEO, MEO, and LEO, I wanted to give just a comparison of what the real differences is of these. And if you dive down into this, and this is a much more lengthy and deeper discussion that what we will have time for today, but really each of these orbital planes are uniquely positioned to provide connectivity that serves specific needs, and that also diversified needs with advantages and also sometimes disadvantages where the other orbital planes will be much more beneficial and can substitute for specific needs and capabilities. Geostationary has always been the old stalwart, if I can call it, orbital plane, where Intelsat in the past and then now SES have really focused majority of our build out of our networks from inception of our companies. This is where satellites sit 36 to 38,000 kilometers from Earth, and they would ultimately turn with Earth, and you'll have a small dish on the side of your house that you connect for direct to home TV applications, or maybe a small, very small aperture terminal, a VSAT terminal on the side of a building, or maybe on top of an ATM that would speak and point in one direction in space, and you would speak to this geostationary satellite and connecting into that wider ground network in the end. Moving down to MEO, whereby the advantage now is coming closer to Earth, but then as soon as you come closer to Earth, you obviously spin around Earth much quicker, and you would not turn with the circumference of Earth. So that would ultimately require you to have slightly more satellites to connect a certain area. Just as a reference, with geostationary, you need 3 satellites to cover the whole globe. If you come down closer to Earth, you obviously need a substantial amount more. Where MEO constellation gives an advantage of lower latency, but then also diversified remote terminals to really access it. This is where you will have 2 antennas that seamlessly would track and hand over from one satellite as it passes Earth, and it would talk to another satellite. So you would talk in a communication cycle to more than one satellite at one stage. And then again, closer to Earth, MEO satellites being anything from 5,000, I would say from a communication perspective, 5,000 to 8,000 kilometers from Earth. And then also LEO satellites and the LEO constellation. This is now where you need minimum 500 satellites and more to have a global coverage, and where you have speedy satellites. And on a very starry night, you can challenge yourself, you can look up to the sky, and you can clearly see some of these satellites orbiting Earth, which then again brings the advantage of even lower latency, but then also some complexities around the connectivity applications or the requirements for a remote terminal. You use a flat panel antenna, but you can't potentially run media services over this, but you can run very effective enterprise as well as potential mobility services over it. So each of these orbital planes really creates a very unique advantage to some of these applications and verticals that we address and are more sought after. Everybody knows a lot of the well-known names like Starlink is very, very prominent in the LEO constellation. As I said, we are, as SES, the only commercial company offering MEO constellations, and then by far the world's largest geosatellite operator as SES today as well. So we are really playing on our strengths through all these orbits, creating effective services for what the market requires. This is while just driving a little bit deeper, and I wanted to keep the slide in here just to reiterate again the advantages of really what all these orbital planes would offer us. LEO-based services is very, very high speed, very low latency, so that is very effective. for certain enterprise applications, mobility applications, as I noted. MEO-based services, this is slightly higher latency than LEO, but very lower latency than what geostationary, much lower latency than what geostationary can offer. But then again, you get much higher throughputs through a MEO-based service. And then with geo-based application, this is the well-tried and tested satellite technology that all of us have used in multiple series across, I think, various applications that you might have accessed in the past. Slightly higher latency, around 500 milliseconds round trip, to a satellite and back to Earth. Which on a phone call, you never really, with the optimization of some of the network applications and the ground infrastructure, you won't really have a real feel of what that latency is. But in some, market aspects like banking and specifically gaming, I think with a lot of you would pursue is that, that latency is not favored in aspects like that, because that 500 milliseconds would sometimes make a difference in what you do on that platform. This slide is very, very, very important for me because we are ultimately at a new era of space technology. I've been in many of these presentations through the Max IQ program, and thinking back today of the presentations and the technology that we addressed 5 years ago, 6 years ago, how fast we evolved to say where we are today. The satellite infrastructure, let me say, the satellite networks in space and the advancement in space is growing at such a fast and rapid pace that it is really mind-blowing to see that we are going into a very, very new era in space. So today we are only talking, and I'm predominantly only focusing from an SES perspective on the communication aspects of these satellites and what we could find in these orbital planes. But there are many, many satellites and specifically designed satellites, pico, femto satellites, nano satellites, micro satellites, mini satellites, small satellites. So each of them with different weight, a different design, different orbits, can access various applications. This can be from Earth observation satellites. This can be weather satellites. This can be, satellites for specific governments that they would design for specific applications, or maybe for across horizon, I would say military applications in certain aspects like this. So really the applications in space is far advanced to what just communication would bring. But why I'm saying it's such an interesting space is that the new space era that we are ultimately going into has changed so much that satellites are now almost like production line satellites, where in the past, from a geostationary perspective, geostationary satellites cannot be serviced as soon as it is launched. So you need to make sure that these satellites, whenever they are built and whenever they are designed, that they are 100% in a working condition, and that they would obviously serve their lifespan, which is normally planned from 15 to 18 years. That being said, the satellites in lower orbits are built very quickly. It's much cheaper. You can launch many more satellites on one launcher, and they've got a much smaller lifespan. If you want to deorbit them, you deorbit them and they would burn up in the atmosphere of Earth. So it's a completely different space and a new space era that we go into. They serve various applications differently, and it's really driving, I would say, the commercial capabilities in space a lot more. The communication was really the only, I would say, commercial viable commercially viable company that you could drive in space was really through communication means. But today, and the vast amount of new space companies that are popping up and the investments towards that is really allowing us in the space industry, to see this as a much wider network and with much wider potential, specifically for students and the likes, is that there is much more capabilities. There's a wider arena for opportunities, and also in the way that companies would look at accessing space. So I would say this is really one of the most interesting eras that we are living in with regards to space technology. And then as the last slide, with as I think as a sign of what I was saying about the new space and the new era which we're going into. SES has recently invested into what we call a direct-to-device. Now, this is a low Earth orbit constellation that will be built out. And the way that you connect with your mobile phone today is through a mobile operator that has got various terrestrial towers connected through fiber, connected through satellite. And these then, if it is data of like 4G, LTE related, or 5G, or just voice, pure voice, 2G in certain markets in Africa, which is still very relative, you would be able to connect in the future directly with your cell phone to a LEO constellation satellite in space. So they call it direct to device, the D2D market. This is still very new in the build out phase and would be still, I would say, anything to 5 years up before this would become a commercial reality in some markets. But the technology is already there. The spectrum is already there. There's already satellites launched, and there's already, connectivity being run over some of these satellites. Obviously, non-commercial at this stage, but from a testing perspective. But you would, in the future, really drive or connect with your satellite differently than what you do today. And it could be that you are doing it through a direct-to-device connectivity application. This is very important for us in Africa, specifically connecting the unconnected. This does not require companies to make the massive capital expenditure to connect and build out networks into rural areas where they might not, for some companies, might not see the value in that. They might not see the return on the investment for doing that. And sometimes these markets or areas get left unaddressed. But through this direct-to-device application, it would be very possible for us to do that. So this is really, I think, the closest we're going to get to driving a new connectivity application from what I presented today, and what is definitely the forefront for us as a company, and that would you as a user would be able to have access to in the very near future. So you can clearly see the exciting period. You can clearly see the exciting time that SES as a company is going in, but also that us as normal users of technology and that would need access and connectivity would use satellite as a medium through the multiple orbits that we can access today.
This industry is an extremely dynamic industry. The pace of change that's happening is incredible, both in innovation, as well as manufacturing, as well as how the supply chain typically works. So the way the industry worked for decades, it's changing very, very fast. The relevance of space, both for governmental purposes, as well as the commercial purposes, is becoming more and more important. The future is very bright for this industry.
July 17th, 2025 was a very momentous day in the history of the satellite industry. Two of the most storied operators merged into one, Intelsat and SES. We are now one of the world's largest global operators by far, and we needed to do this at this juncture because our industry is in a state of transition. Well, the space industry today offers immense opportunities, connecting people, things, planes, ships, government drones, cloud computing systems, and distributing video content across the world. We intend to address that surging demand by investing and innovating in some core technologies. Both our GEO fleet, our future MEO fleet, having access to our LEO partners, and investing in ground, terminal, and software technologies as well.
This merger makes all the sense in the world. It just puts us in a much better position to be able to scale our business, to invest in technology from a satellite architecture standpoint, to be able to provide the services that our customers want over time, to put the right team on the field to be able to provide the level of service, the quality of service, the resiliency, the ops model that our customers expect over time.
What's most important to us is to focus on three important things. Number one, relentless customer satisfaction and solving our customers' problems. Number two, having a multi-orbit architecture that can solve those problems. And number three, investing and innovating in a dynamic digital ground network and advanced terminals for the future.
this merger has been absolutely wonderful, especially in terms of what it's going to be able to deliver to our continent. And I've made a special note of direct to device, because I completely agree with you. This is going to be the leapfrog for the African continent, because space hardware is now infrastructure. It's basic infrastructure. We don't have to put in cables. We don't have to build towers. We don't have to put in fiber, all of that. We're going to be able to leapfrog to connecting a device. And, you know, a hand-me-down device, it can be a 5, 6, 7-year-old device, and it's still going to be able to connect, you know, to local networks.
Denish, the founder of STEM Center Africa. We are based in Kenya, and we offer STEM education programs. We have a number of programs for students ranging from 4 years to 21 years. That's the age range. And we have been working with Ms. Judy for a long time. Like, we had been implementing the Max IQ and also the Intelsat space program. I think there's one which is currently ongoing. We have 23 students who are participating in the program, and they really love it. They're really very much curious about space education, space science, and the gadgets or the kits that you sent. They're really enjoying. I'm glad that nowadays they are thinking of, oh, can we send something? They're thinking of, oh, if we send this thing to space, what will happen? So in other words, I'm just very much grateful for the team that have been supporting us to ensure that we instill this space science curiosity in our students. And just to add on that, currently we have an invitation to participate in one of the, I think our students have been invited to go to the United States in Indiana, where they are going to participate in a related program. We call it the Near Space Education. So they are going to do the balloon launching and the rest, which is similar to what we have been thinking. We have been talking about with Judy. I remember last time we met and we were thinking of, we want to do similar thing in Kenya. So thank you very much. I'm glad to join this meeting and also to learn more about the new things that are going to, like, based on the email that we are going to discuss. Yeah, thank you. Yeah, maybe I can start. First, thank you. Thank you, Hans, for the nice presentation. It's just reminding me my time when I was doing geography in high school. Like, we were talking about those, like, as I was presenting, I'm just like trying, but later I deviated to do math, so that's what I've been doing. Okay, so thank you very much for the presentation, and it's been our wish as maybe from STEM Center, I'm very sure from Caroline, someone I know doing amazing work there. It has been our wish to have this space program fully implemented for the kids, because we talk about this, especially once we introduce this through Ms. Judy. We have been thinking of how can we get support to fully have some space station, maybe ground something. I don't know the exact terminology, but it has been our wish to have this thing actualized, because the truth is, and we know this, we don't have robust space program in our African continent. I know there's a space program in the government. I think there's the department dealing with that, and a number of stations maybe in Africa, but the younger generation who will be the future leaders, we feel there's a big gap. And it is true, because such programs are not there if I compare with maybe in countries like US and the rest. So maybe, I don't know whether it's good to ask it now early, but I'm just putting it to you here, that can we get a nice support whereby we are able to bring this to our students at this early age? And I believe if you go with the mentorship that you people will be offering, because I know Judy has been talking to them, meeting them, and you can continue to have this nice space program, I believe you are going to help our continent and the world at large. So my request and maybe a question is how we can translate this nice presentation and the nice work that you've been doing so that we are able to bring this to our students, because we are dealing with students from like we are centers. So students come from different places and they come. Sometimes you have the mobile program whereby we go to students in different schools. You organize the science fairs. So how can we bring or maybe get some support in terms of the material, in terms of other forms of support in order to actually implement or create a space program for kids? Yeah.
Yeah. Danish, I think definitely that the time to now really push in that direction has never been, I think, more viable than when we started with this program. And the reason for me saying that is that space has become such a talking point, and a lot of governments are now engaged with us, as well as I've seen picking up on their space programs. I mean, this is countries like Angola, South Africa, Mozambique. We're actually meeting with the regulator. One of my team members are meeting with the regulator today, specifically around, something around imagery satellites that we're talking about, communication needs, and on a border area and certain aspects like this, where they now all talking about suddenly becoming, managers of their own space programs and or launching their own potential satellites. And this is not just communication satellites. This is satellites. This is weather satellites. Angola specifically, again, as an example, has just ordered to weather satellites that they're building out, for monitoring of certain aspects that they need from a governmental perspective. So we can definitely take this question back internally on our side and see how we could, with our reach, have access to call it the ITU, maybe it's the World Bank, maybe it's some of these entities that would drive programs or invest towards kids and or startups for specific programs. New space is very relative, and I actually read this morning there's a program for hosted by New Space, and one of the conferences coming up in Gabon later on the year, where they've got a program for innovation drive, where they're putting it out to specific people or students, to bring anything innovative to the forefront. So there's a lot more focus. That's what I ultimately want to say. I think from SES's perspective, I'm happy to take the responsibility to speak to people internally on our side to see maybe we can put you in contact with one of these larger organizations, and for them to see what their planning would be for maybe learners in Africa around STEM, and or injecting more resources, future resources into the workforce of the future, into the space programs of tomorrow. So we still have far to go, but I can tell you we have already come somewhat since we started this program a couple of years ago, I feel.
Right, Hans, thank you very much for that. And Dinesh, I completely agree with you. If we think just only a few years back, 3-4 years back, when we started talking about it, when we were talking about a space STEM program, a lot of people would push back and they would say, oh, but space is expensive and space is not for us. It's only for like maybe 1% of the population. Whereas now, actually space is ubiquitous. If we don't understand Earth observation, and if we don't understand the role of space in everyday life, we actually, in a way, we're going to be missing out. So yes, thank you for that. And Dinesh, I must say, what I really also admire about you and Caroline and your organizations is you continue pushing, because it's all about the youngsters you're impacting, and you're never shy to ask, which I love. Because the worst answer you can get is maybe a maybe. But a lot of the times you're going to get a yes. So absolutely. And Caroline, please go ahead.
Yes, thank you so much, Judy. And thank you, Hans. Yeah, I joined a little bit, I think 10 minutes late, but I'm happy to have engaged and to understand the collaboration between Hans and Judy's Intersat. So, yeah, I'm also a founder of Women in STEM Initiative. We empower girls in STEM in Kenya, and we've been doing so much. And actually, we are still going on with our project, the Intelsat STEM Space Project. And but there's one thing that just the same way Danish talked about, we want to know what next after this project because the students are really curious to know more, to learn more from the space, and we don't want to leave them hanging because we've started a really long journey with them. Yeah, we want to continue this engagement and also see how far we can include more schools because here in Kenya, um, space education is not very popular, and teachers are also not very much aware about what's happening with STEM and space. Yeah, and basically we are currently in a new curriculum, the competence-based education curriculum that requires students to have skills for the future workforce. Yeah, so we are really emphasizing on problem-solving skills and creativity, critical thinking. Yeah, so we're doing so much on STEM clubs in schools. Yeah, and I'm happy because STEM space education is going to be very popular once we are able to engage with Hans and Judy when we continue with the engagement because we've been doing so much on Arduino, robotics, and the students still need more. And so we're looking for more better programs that we can include. Yeah, and I'm happy. I'm looking forward to even career opportunities because this is one thing that Judy talked about in the email she sent that really made me feel like I need to attend this webinar. Yeah, because of the career opportunities, the future opportunities that may be available from these engagements. Yeah, especially for the African space industry. Yeah, I'm very open to that. Yeah, thank you so
Yeah.
much.
Thanks, Caroline, and it's good to meet you. Again, I'm going to start reiterating that I think the time for us is really much different than it was, and I think we've got a lot more options that we could pursue. I will definitely again take the question back to see how we could maybe flip this a little bit different. I think and maybe look at it just a little bit more again on the learner side and see where we could give them reference on the potential of programs out there after their schooling or after the successfully created the interest through this program. How they could look at maybe a future into this industry. I must also say that there is a much wider market and potential out there today as well. Like I alluded towards, the access now to the multiple orbits really create an environment where you get companies that manufacture components to launch on these low Earth orbit satellites, and they are African-based companies. They're not US-based companies. They're not European-based companies. This is companies, very credible companies working on large programs that manufacture components, and they're based in Africa. You get companies that are launching small satellites, specifically Pico and Femto satellites, is that really, I think we need to create a database of what is else out there besides SES. SES fulfills such a pivotal role in this industry, specifically in the communication arena. But I think we need to also see what, whenever the learners are successful or whenever they show interest into this, space arena, that what else is there for them to look at? Because it's a daunting world. If you don't know it, you don't know where to go and have a look. And I think creating a database around these potential entities would really give them an opportunity, to go and see where they can pursue some applications. I actually had the opportunity of speaking to one of these new space companies not too long ago, and one of the questions that I had for them is, where do you find this workforce? They had over 140 people in employment, and they started at universities. That's where they started. They started with obviously credible engineering resources, obviously being very rich in from an engineering perspective, I think that's where they normally start, but that's where they started building up, their workforce. So there's definitely way more opportunities for kids, I think now, or students rather, to look at a very credible career in this industry. And then I can't reiterate enough that governments are really stepping up. I cannot, and African governments, I mean, just look at the space program in Egypt. It is massive. It is really, really massive. And, the space program, Israel and India, to give you another example outside of Africa, is probably one of the largest satellite operators in itself by the amount of satellites that they own and operate. So there is a lot of, there's a big network out there, and specifically, I say governments and regulators are taking responsibilities more than they ever did, I feel like.
Great, Hans. Yes, thank you very much. And I've made a note there for us to have a look at doing a module in the program that has a look at the ecosystem, the much broader ecosystem of the space industry, and where are those career opportunities. Because yes, whatever we do on Earth, we're going to need to do somewhere else one day. So how can you become a medical technologist in space, on the moon, on Mars? All of those sorts of things.
And maybe just a small comment on that, Judy. I mean, we continue to speak about the innovation of space, specifically for the students here, and I think this program is very much entrenched in that as well. But we are innovating in this industry just as hard on the ground segment, applications. This is really where the much needed design is, because I think the concept and the science in space is already, that's already established, and the satellites will be built out, and obviously that advancement will grow. But really, the problem for us connecting satellites coming lower to Earth is really the ground segment stuff, and there is tons of companies stepping up. I mean, I've done a bit of a research on these companies quite recently, where you get companies in Paris that manufacture specialized antennas that you never had. It was normally always the US-based, large companies that was more focused on the geostationary side. So there is, as much as we look at this ecosystem in space, I think the ecosystem in ground, which will have a very credible career in space, but obviously more from designing, implementing, and even operating and building of these networks on the ground is much more relevant and much more needed, I feel, as well.
Absolutely. You're very right. Daniel, I was wondering if you would like to unmute and come in with some questions or contributions of your own. And introduce yourself.
Good morning, good afternoon. I'm actually in a noisy place, so I dropped a message in the chat, but I will just go on to speak. Thank you, Mr. Hans, for the wonderful presentation. I really learned a lot. I'm someone who has been so familiar with space tech and the trends. I had a lot of questions, like technical questions to ask, but I am a professional in the telecoms industry, the terrestrial network from space, and I also have a little background with SAT communications, where I intern. I'm also an informal educator. I do organize boot camps and space-based workshops and conferences for young people. So I really want to appreciate what Judy has been doing. Former Intelsat, now SES. You guys are doing a very, very great job. My question is in line with what my colleagues have said earlier. I have questions around supporting, because some of us might have ideas and initiatives. Like I do annually. I do organize a boot camp or a fair where we have students come from different schools, and they get to see exhibitions and take lectures, and also participate on project-based activities all about space and astronomy. So I don't know, are there ways, and one of the challenges with having is, of course, finances and some other technical support. So are there opportunities for that, for support? And I also want to ask about internships and excursions. Is it possible for maybe a program for internships? Because I also deal with university students, and I've discovered that it's very, very, very sad, even in Nigeria, where we have a space program. Much attention is not given to even the students at the university level. So I also have interest in. I also deal with university students, especially in their first year, second year, and they are really lagging behind. So I just want to know if there are opportunities, exchange programs, discussions, internships that can be curated to help push this forward.
Yeah. Daniel, good to meet you. I hope I got your question fully. It's more, I think from additional potential of investment opportunities to really, expand this program a little bit further. I hope that's the correct alignment. I didn't get all of the question. Again, I think with my earphones and the noise, I didn't get all of that. But answering in line with that, there is already a lot of companies that does internship programs. We are, as SES, doing internship programs globally. We have not actually pursued that as a new code today for Africa, but I think this is something relative that we would 100% look at in the future, where we would pull in potential interns and see how we could scope them, and also use the best of the resources, give them a platform to step up, and then also potentially capitalize on some of these candidates that whenever they do have the capabilities or to pursue a directional career, and they might be successful in that as an intern. I don't have an answer or a really confirmation on that, but I know we do, as Intelsat, we've done it extensively in some of our other global offices. And looking at again the question of expanding this, I think what we've done up to date and how we've progressed this program from inception is exactly that. I mean, we've grown quite a lot, and I am super proud whenever I present this to someone, wherever we speak about this someone, to really see how much more candidates we are really accessing and exposing to this from where we started. So we should really focus on, and again, whatever we're doing now, expanding our view from this program, see where there would potential for us to really benefit from whatever we've done in 2025-26 program. How we're going to do that in the following year program. I think SES is very committed to this program, and I mean from a commitment perspective, we're happy to see the success of this growing, even through it being originally an Intelsat program that's now been taken over by the merger of Intelsat and SES. We are happy to pursue this even further. There's a lot for us that we can do in this program. A lot of your question I can't answer or confirm now, but I think just purely stating as an answer that there is a lot more that we can work with today as SES, as Max IQ, as the students, as the market delivers and offers us, as the opportunities of expanding our horizons of this ecosystem ultimately, that we could look at really growing this exponentially together.
Yes, Hans, thank you very much for that. Yeah, Daniel, I think we picked up kind of like the gist of your question. There were a few questions there, and one of them also related to how could we have opportunities for some of the youngsters, the real top performers, those who are really enthusiastic and motivated in the program, for them maybe to be able to attend, even if it's a virtual conference, something like that, actually start, being introduced to industry that way, possibly, in the let's say the last 2-3 years of their formal schooling. Daniel, I think that from my perspective, my suggestion is we have a group that we've a cohort of us who've been together for a year now. And what I would like to do is that I would like to actually that you make a lot of suggestions. Everybody, please Daniel, Danish, Caroline, Jonah, Dauphine, please make these suggestions, because often as corporate people in global businesses, producing products and services, etc., often we don't actually think about these things. Often we don't see these opportunities. You are all in the ideal position to be able to see, this could work, that could work, that could work. And let's actually just have all of these suggestions. We're not going to get a yes to everything. But the thing is that if the suggestions come from you, then as we innovate the program and as we redesign every year, it's always going to be so much closer to what's really going to make an impact. So yeah, please, maybe in the learning management system, there is a discussion forum. Let's actually just start, and it doesn't have to be pretty and it doesn't have to be tidy. Just let's start plowing in ideas of what we can do so that we can then present that to SES as a little bit of a wish list that we can then work from there. Jonah, hello, thank you for joining us. Jonah, you're joining us from Senegal, if I'm correct. Please introduce yourself and if you have any questions for Hans.
Thank you, Judy. It has been a long time. Happy New Year, everybody.
Happy New Year, Jonah.
Pleasure to meet you on this webinar. This is Jonah, not really from Senegal. Jonah is a Kenyan citizen and a team leader in Kenya's STEM Alliance. Judy, thank you for this program. We joined it courtesy of your efforts, and we appreciate. You have said something concerning what we can give as our suggestion, because we interact with learners on a daily basis. Now, SES and Intelset discussion like this can really give us a wider scope. And I would wish that as we interact with our students in our classes or in different fora, then we would look at satellite engineering as another avenue where we may have students taking that scope. And so we need to dig deep and look at the following. I will just highlight, I'm talking about satellite engineering, space data analysis, and these children can start from very humble beginnings. As they progress, they will have anchored that foundation. Number 3 is telecommunications. And then we have remote sensing, climate and earth observation. Because with the STEM, with the STEM space technology, we can as well observe things right from the sky, and we look at what is down on Earth. And so that would bring us to climate and Earth observation. Then we shall look at aerospace technology, robotics for space, space policy and governance. Because that really will also help to guard us against other people who may have bad intention using technology on what is really not benefiting the human. And we know science exists to serve humanity. Another area I would wish to look at is this can also help us to really anchor on healthcare, doing a lot of research, making learners also look at STEM, give it some kind of medical perspective so that we also use it to improve our healthcare. This will also help us in doing rural connectivity in terms of networks and all those, because there is no way you will have to do all these things right from the space if there is no connectivity that will relay the information to the gadget that we use. We shall also be in a position to do climate monitoring. We have seen cases of where we can never predict our weather because of effects of climate change. And that's why Kenya's STEM Alliance embraces things to do with ecosystem. And with all your technology and all those insights, that we shall be in a position to make it even better. We shall be in a position, by observing the Earth from the space, we shall be in a position to improve our food productivity and look at agriculture, make predictions and look at what is it that we are able to do, how is the soil like, how is the earth, so that we look at all factors of production consumption. And then we can also monitor the climate and make predictions. Lastly, we can also go ahead and use all this technology and respond to disaster. Many times we have seen many things happening in different countries. I think last year we had got some kind of wildfires in the US. We have had many tornadoes, many catastrophic, advanced climatic conditions that are causing a lot of things. So I would wish that maybe as Kenya STEM Alliance, we shall have to focus on all those and look at even smart agriculture. Where if all these things fail, then what are we supposed to do? We need to feed, we need to do other things and feed our animals and make some progress. So Kenya STEM Alliance is really focused. And maybe for your information, as I wind up, Judy, we are looking forward to anchoring a very powerful foundation so that we have STEM Education Center. Already we've had different members from Europe and from the US who are partnering with us. We want them to own the program. And we also had members of the board. So far we have 6 across the globe. They are willing to support us. And so with such a program and with such kind of deep insight from different people, we are hopeful that we shall be somewhere. Progress is progress, regardless of its pace, I think.
Jonah, thank you. You've clearly highlighted the breadth and the depth of the potential, and I can't agree with you more. In your discussion now and or your layout, it is clear that there's various things that's part of this whole ecosystem that we obviously didn't talk much about this, but the way that AI is going to be incorporated in networks and the way that AI is going to be used in ground infrastructure, in the way that satellites are operated, is definitely going to be a reality. I don't think we are fully utilizing that. I know, and I'll give you an example, commercial companies like Ethio Telecoms have incorporated AI to do clever management of their generator resources. So when the site's not fully utilized, it would switch it off, or it would go on solar and generate it as fully utilizing the power. So which is a clever way of doing it. But I think the learners of today would really have to, they've adapted that mindset, and incorporating that into the networks of the future will be very important. And again, I cannot overstate this. Governments are taking note. I think there's definitely a responsibility on us and the programs that you run to really drive this messaging into government, and specifically into these governments that are giving access to these new networks. All these LEO constellations require licensing. These corporates invest millions and millions into ground infrastructure in these markets, and so the governments and the regulators are very much involved in this, and they're very much aware of this. And I think we need to play at that with regards to driving them to commit to potentially investing and or supporting programs that would benefit them ultimately as a government, and as a population in that country, for the workforce of tomorrow.
Yeah, absolutely. And yes, Jonah, I must apologize. I'm so sorry about that that mistake I made. You're very right. There's this whole breadth, there's this whole architecture of applications for space technologies. And Hans, I really like that you've brought up AI. In some circles, especially in education, there's a lot of fear of AI and using AI. But certainly what it is, it's a very powerful tool. And powerful tools are very, very, very useful if they are used properly. it's a bit like a jackhammer. If you know how to use a jackhammer, you can do, you can really do quite a lot with a jackhammer. But if you don't know how to use it, it can be a very, very, very dangerous instrument. So, yes, we've seen some really interesting examples of how AI has been used analyzing Earth observation data, especially in terms of early warning systems, things like that, early fire detection, early flood detection, etc. And I've actually read a very short article this morning, and that is that the South African National Space Agency, we have access to satellites that are sitting at Lagrange points that observe the sun. And they have detected that we've got what is known as a level 4 solar flare event, which is really going to affect our telecommunications on the planet. And level 4 is regarded as severe. It's kind of like in the middle of the range. But yeah, that is a really great application, because what it means is it really affects the navigation systems on aeroplanes. It affects our connectivity, our internet connectivity, and that kind of thing. So being able to have these early warning systems is very valuable for the entire planet, not only for ourselves in our own countries. And I see that Dauphin has unfortunately needed to go. Danish did send his thank you very much. He needed to jump off at the top of the hour. And so what I'd like to do is, Christelle, I'm not sure if you want to make any comments or ask any questions before we close.
You know what, Hans did such a great job with the presentation, and I don't have any questions. So, but thank you, Judy, so much for supporting this program. We've been busy for the past 5 years now, I think it is. And yes, we need to look at how the future looks, as well as how we could expand on the program. But certainly very excited to support and stand with Hans on this one.
Great, Christelle, thank you so much. And yeah, to the team joining us, we had a fantastic first 6 months of the program last year. There was a little bit of unsurety what was happening with with Intelsat and the merger and everything else. And what I'm pleased about is it's only been a few months, and we out of that, we have clarity. We know now. So we're continuing with the implementation of the program all the way through to the end of April. And yeah, Hans, thank you very much for this workshop, because this was kind of like our let's get back into full speed. We've had because unfortunately our workshops did kind of like slow down, and now we're back. It's January, we're back full speed. So thank you very much for the session today.
Only a pleasure, Judy, and thank you for you, and thank you for everybody online for all the hard work you do. We all share the same passion, and I think that's very important for us continuing with this. And again, stating the obvious that I've mentioned many times over in the school, we are honestly in such an interesting space, and no pun intended saying that, with regards to where this industry is going. So there's a lot more for us to come. There's a lot more for us to talk about. The innovation has never been driven as hard as it's being done currently. There's never been so many companies investing and really putting their backing behind the future in space. And it's not just communication. There's various verticals and applications that's being served. And we really need to capitalize on this. And I think you're all very well set for that. Of sharing that passion then also for the learners. And I think what we need to do is make sure that they understand it, that they've got a wider scope, and that they understand, this space arena really. Because even for me, being part of predominantly the communication space for over 20 years, it is a new world there. I've really done a lot of reading and resources, check up on really the type of satellites, who's building it, how does it work, the component manufacturers and so forth. And it is spectacularly interesting to see where this industry has gone and how quickly we've done it over the last, I would say, 5 years.
Absolutely. Great. Bjarke, Hans, I don't think you've actually met Bjarke. He's the developer and inventor of all of our hardware and software platforms, etc.
I think we had an opportunity to meet previously on one call.
Yeah, we have met beforehand, but maybe not live or in person.
Yeah, and Bjarke, late last year, Bjarke delivered a workshop on living on Mars. How are we going to live on Mars? What do we need to do?
Not that I have any experience, I just want to say.
Sorry?
Not that I have any experience on living on Mars, but I can guess.
Absolutely. Bjarke, I'm going to hand over to you for a minute.
Yeah, so thank you very much. Very great presentation. Now, we do a little bit of other space stuff other than what Judy always mentioned. So I just checked here before we started. We have sent a ground station to Antarctica where we are listening to satellites that transmit using LoRa mainly, but there can actually be other transmission. And we have 2 ground stations there, one listening on 4.33 megahertz per second and another one listening on 137. So there is a network called TinyGS, so Tiny being tiny and GS being ground station. And we have 2 stations running here in Cape Town, also running on these 2 different frequencies. And the ship went to Antarctica here in Christmas Eve, I think it left, and has probably arrived or soon arrives. And then once they get the generator fixed, which they have to get fixed there, then they're gonna install our ground station. We got a dome that not being used for anything. So we have a whole dome to run something that actually only take up like less than the space of a credit card. So so we have that running. And the only thing, Hans, and this is going to be a technical question, do you any of your satellites transmit free telemetry using LoRa? Are you aware of that?
No, not that I'm aware of. But I can, if you let's connect, outside of the forum, and I'm happy to see that I can put you in touch with the right people. But immediately it struck me that I wouldn't say yes.
Okay, that's great. Judy, you misspelled TinyGS. So yes, so for those, it's a little project where there's ground stations around the world, not many in Africa, but there is a lot of these around the world, and it takes not a lot. Actually, this is kind of like the size of the ground station. I need to plug a radio in here, but that's actually the smallest part. And that then the way it works is a downlinks telemetry data whenever satellite flies over, and we then upload it using the internet to a central database where everybody who is part of this TinyGS then listen in here. So there is thousands of ground stations around the world, and there is a couple of hundred satellites now that transmit. There's a lot of Chinese satellites that transmit on that thing. And then, Hans, I don't know if you remember, but there was a satellite company called Swarm, Swarm Technology, Swarm Sats or something like that. They launched half-view, CubeSat half-view satellites, and FCC slammed them with a big fine because they have to be at least 10 by 10 by 10 centimeter. And they then launched them with, I don't know, some other country. Anyhow, that been bought up by SpaceX, and they were transmitting using LoRa. So SpaceX is transmitting LoRa on their satellites. Anyhow, there's a lot of other satellites that do that. So there's a lot of student satellites that do this thing here, and a lot of other satellites just do it because, hey, it's a small radio, as you can imagine. And therefore we have this thing here. So I thought it's gonna be interesting for us to see, because one of the interesting part of setting up a ground station on one of the poles is, of course, when you have polar orbiting satellites, you see them every time they fly over, and not only 2 times a day. So we get hopefully much more data sitting. We are not sitting there. We are just, and luckily it's the peaceful South Pole right now, not the other end of the cold places. So yes, Judy, thank you very much. That was very, very enlightful.
Thank you, Bianca, as well. I just wanted to say the SI Agulhas that normally sails to Antarctica, we are connecting that ship via one of our satellites.
Okay, great. So we are there. Cool. Thanks. Yeah.
That is great. Yes. What I'll do is I'll share with the group. There's a really great documentary that's been made on the Agulhas 2. It's the first of its kind icebreaker that's actually been built as a research ship that can also accommodate people, because there's about 80 people who go once a year to Antarctica, and then 50 come back, or so 50, 60 come back after 3 months. The rest stay for much longer. Great. Hans, thank you so much once again.
Thank you, Christelle, as well. Together, Christelle and myself, we're very much involved in this program. We would be driving it from SES's responsibility perspective, and obviously very engaged with you, Judy. Can't thank you enough as well. But happy to support today, and looking forward to the program continuing then into 2026, as you said.
Thank you. And thanks everybody for joining us from across the continent. And what I will be doing is that I will be making an edit of the video that I'm going to upload then for everybody and send to everybody. So with that, thank you for a great afternoon. And we'll see you.
Thank you. Thank you, Judy. Thanks everybody. Thanks. Bye-bye.
Bye.
Bye-bye.